All right, guys, you are on your last day of STAAR review. I'm sure we are all thrilled to be almost done. Today we're going to focus on linear and exponential graphs. So if you'll take a look at your first page, okay, you are asked to find the rate of change, okay, for several different questions. Okay, so you'll see rate of change here. Rate of change here. Okay, if you look over on this other column over here, again, we're looking for rate of change. So let's just kind of review what rate of change means. When you are doing a linear graph, remember that it's y equals mx plus b. Okay, this number right here, the number that is with the x, that is your slope, which is also called your rate of change. And the rate of change can be found in the graph by doing rise over run. So essentially what you need to do is find two pretty points on the grid, and then you're going to count how many boxes did they go up, how many boxes did they go over. So if I'm looking at number one here, I see my pretty points are all labeled for me. Okay, so rather than doing this example with you, I'm going to do number 3 with you, which is right next to it. Okay, but for number 1, at least, you already have those pretty points labeled, which is kind of nice. Okay, so let's come over here to number 3. So I'm looking for some pretty points. So I see that right here's a pretty point. And the next pretty point it looks like is right here. And then right here. And then right here. Okay, so the first thing that you want to do is mark where those points are. Then the second thing you want to find is the rise over run. Now, remember that you're not really just counting boxes. You're actually wanting to also take into account how much each box is worth. So if I'm going, let's say from here to here, I have to go down 2 boxes and then over 1, 2, 3 boxes. Okay, but here's the problem. If I'm going down 2 boxes, look at how much each box is worth. So I'm going down 10 and then 10 again. That's actually down 20. Okay, then I want to count over. That'd be 1, 2, 3 boxes. But you'll notice that on the x-axis, it's like 1, 2, 3, 4, 5, 6, 7. So I'm not counting by like a larger number. So that means over 3 really is over 3. Okay. Then from there, you should have your Desmos up, just like we've been doing pretty much all week. So I am going to come over here to my Desmos, and I'm going to put negative 20 over 3. So I see that negative 6.66666 and negative 6.5 is the closest match. So that's going to be F. Okay. Now, sometimes you'll notice this on some of the other questions. They'll want only fractions as answers. So if you click this button right here, it'll actually reduce it back into a fraction. Okay, so in this case, it gives you a decimal, but if you needed a fraction answer, you can just click right here. Okay. All right. So you're pretty much going to be doing that for this whole first page. So if you'll go ahead and turn to the second page, please. You'll notice that on the second page, instead of having graphs, you have tables. Okay, so if it's a table, your equation is still y1 or y equals mx plus b, but you're going to have to change that to y1 squiggle mx1 plus b. Okay, and remember that what that formula does is it's going to take whatever table you're looking at and turn it into an equation. Okay, so if they give you the graph, just count the rise over run. But if they give you a table, like this question right here, then you're gonna use the table in your Desmos here to turn it into an equation. So let me remind you how to do that. You're gonna start off in Desmos by hitting the plus button, which is right here. You're gonna add a table. And then you're gonna take these numbers from right here and type them in. So -2037. Then I'm gonna come over to my Y side and put these numbers in here. So I have a 12, a 3, -10.5, and -28.5. Okay. So once I've typed those values in, I'm taking all the numbers from this table right here. Okay, then I'm gonna come down here and put this formula that I have right here, Y1 squiggle, MX1 plus B. And then you'll notice that right down here pops up my M and my B for my equation. Okay. Now, another thing I do want to point out is that you should only be using this equation right here if it's linear. So do you see the word linear right here? That's your hint that you're doing this thing. Okay. So let's write our equation. It's Y equals, it tells me on the screen here that my M is a -4.5 right here. So that'd be -4.5x. And then my B, it says, is a +3. Okay, then remember that you should know the difference between what each of those numbers does. The number with your X is your slope. And the number at the back is the y-intercept. So if they're asking me for the rate of change, okay, remember what we said on the front page, rate of change and slope are the same. So I know I want my answer to be -4.5, but the problem is that all of my answers over here on my worksheet, okay, these are all fractions. So what I can do is just see which of these fractions are the same as 4.5. So if I do 2/9, that is 0.222. That is not what I want. -9/2. Let's see what that is. Okay, oh look, -4.5. So then B is going to be our guy. Okay. So you're going to basically take your equation or your table, put it into the Desmos calculator, put in your Y squiggle equation, and then rate of change is referring to the number that is with the X. So it'll be whatever your M is. Okay. All right, we're gonna do one more off of this page. Let's do number 7. Number 7. Okay, so first thing I want you to notice is that it does say that it's a line and linear. Okay, and it's asking you for the slope. Gives you 2 ordered pairs here. So the first thing that I'm going to do is I'm going to take those 2 ordered pairs, and even though they're coming to me in parentheses, I can turn that into a table very easily. Okay, just put your X, Y at the top. 26/7 is my first ordered pair. -39/12 is my second ordered pair. Then I'm going to take this, put it into Desmos, and then do Y1 squiggle, MX1 plus B. Specifically, also remember that the slope is going to be the M. Okay, remember also that we said that's called the rate of change sometimes. So if they ask you for slope or rate of change, that's the exact same thing. So let's cross out these old equations and get started. You're going to click your plus first, add your table, plug in your numbers. So 26 and -39 down the X side, And then down the Y side, we're putting a 7 and a 12. Then I'm gonna come into my line 2, Y1 squiggle, MX1 plus B. And I see my M right here is a negative 0.0769. Okay. So it's negative 0.0769. And then it tells me that my B is a 9. So that's my equation. But then remember, specifically, I'm looking for the slope, which is this answer. So then all that I have to do is type in each one of these answers one at a time until I find one that matches this number. Now, one other thing I want to point out is that your B and your D are both positive. So we can pretty much throw those two answers out because we know that we want this to have a negative in the front. So out of my 2 remaining answers, let's see which of these are the same. So -1/13. Okay, boom, I recognize that decimal. That's the exact same as this decimal. So your answer is okay. Okay. All right. So that should be enough examples for you to mostly finish page, this entire page. Number 10, I just want to give you a little hint. Okay, we've talked about zeros. We actually talked about them last class. But it says you have a graph of a linear function. Okay, so take a look at number 10, and it's asking you for the 0. Okay, you should know that a 0 is the same as an x-intercept. Okay, so I'm not going to do that one for you, but whenever you see the word 0, that's where it crosses this line right here. Okay, so you would just look and see where does it cross. That would be your answer. Okay. All right. So for 7th period, Mr. McCormack, if you want to pause the video, give the kids about maybe 15 minutes to work or so. And then we'll go on to the last page after they've done a couple of examples. Okay. So if you'll hit pause right now, that would be great. All right, hopefully you have finished quite a bit of pages 1 and 2. We are now going to go on to the last page, which is your exponential equations. So your exponential equation formula is y equals AB to the x. Okay, let's make some little notes here of what each of those numbers stand for. So the number in the very front is always going to be the start amount. And the number in the parentheses is going to be the base. Remember that if your base is bigger than 1, it is growth. And if your B is less than 1, it is decay. Or we'll say maybe decreasing as a less confusing word. Okay, so growth if that base is bigger than 1, decay if that number is less than 1. Okay, so we're going to do maybe like 2 of these off this page, and then you'll have the rest of the class to finish. Let's start off with number 11. Okay, I kind of scribbled on it, but hopefully you can still read it. So it says a student used that equation to show how the balance in a savings account will increase over time. What does the 5 represent? So look at your equation. Okay, the 5 is the number in the very front. And what does the number in the very front represent? The starting amount. So let's read through these answers, see which one says that. Okay, the interest in the savings account? No. The annual interest? No. The number of years the savings has earned interest? The starting balance of the account? Yes. The number in the very front is the starting balance. Okay, next question we're gonna do together is number 13. Number 13. Okay, it says, scientists are studying a bacteria sample. We gave you the equation right here. Okay, it says that equation gives the number of bacteria at the end of X days. Which statement is the best interpretation of one of the values in the function? Okay, well, before I even read through those answers, I'm going to go ahead and label which number is which. This is the start amount of bacteria, and this is the base. And then I'm going to ask myself, is my base bigger than 1 for growth or less than 1 for decay? So if my base is 1.12, that means that this is growth. So now let's read through our answers and see which one sounds correct. First one says the initial number of bacteria is 12. Okay, that is wrong. The initial number is 245. And if you don't know what initial means, initial and start are the same thing. Okay. The initial number of bacteria decreases. Okay, decreases and decay are the same thing. That would only be if my base was less than 1. Okay, but we see my base is 1.12, so it's not G. The next one says the number of bacteria is increasing at a rate of 12% each day. Okay, increase makes sense because increase and growth are the same thing. Okay, the last one says the number of bacteria at the end of day 1 is 245. Okay, that's wrong because remember, what does the 245 stand for? It's the initial amount, not at the end of the first day. Okay, it should be the very, very beginning amount when it started. Okay. All right. So let me look through the last of these. Maybe last one that we'll do here. Let's do number 40. And obviously I got lazy and stopped numbering these because you do not have 40 questions in this packet. Okay, take a look right here. Says the table contains some points on the graph of an exponential function. Based on the data, which function represents the same relationship? So remember, it's y equals a b to the x. And if they give me a table, then remember that I can use Desmos, okay, to turn that into an equation and match it to look like one of these. So, so you're going to go into your Desmos, type your equation in. Let me pull mine up right here, please. Okay, sorry about that. So we are typing in our values. So 0, 1, 2, 3 in the left column, 0.625 in the second column. Oh, and I'm noticing this is an 0.625. So let me fix that. 0.25, 1 and then 4. Okay, so I can see my points right here. And then remember that if I want to turn this equation into, or this table into an equation, all I have to do is y1 squiggle, AB to the X1. So notice you're using the same formula that we have right here. The only difference is that you're adding in those little ones here, here, and then you're turning this into a squiggle. Okay. And then I'm looking at each of these answers to see which one matches. So my 0.0625 needs to go where my A is, which is in the front. My base needs to be a 4, which I can see right here happens in letter H. Okay. All right, so at this point, you should be able to finish that. I am leaving the key with Mr. McCormack. You're welcome to check your work with him. Make sure that you put your name on your packet and turn it in by the end of class, and you are done with STAAR review. Have a wonderful, wonderful day, and I will see you guys on Friday.